Hi, I'm Georgia, head of products in Gucci Digital. You will spend some time, like a few minutes with me. I'm just contextualizing then the core of the speech, which is going to be led by Carlo Bottiglieri. Hello, I hope you are fond of Game of Thrones. If not, well, let me tell you why I added this slide. This was pretty much our word a few years ago. I mean, 1.5 years ago. A clear dichotomy between IT and business. A roadmap severely imposed by business stakeholder. Our only conception of value was increasing sales. Sometimes we were also discussing reducing cost, but definitely customer value was not even in the radar. Of course, in the world of disrupt, otherwise you get disrupted, we had to change. And we, Carlo and myself, but the entire organization behind us, really had a dream. I mean, building an adaptable and learning organization. So, this is what we did. We started from a traditional organization with IT and business siloed, with lots of layers, which of course end up like creating a lot of bottlenecks and a lot of like, checks, gates in terms of like knowledge, approvals, expertise, to what you see basically at the bottom, which is who we are today. It's a modern organization where at the top you see product and tech. Actually, I mean, for me, it's even weird to talk about product and tech because effectively we call ourselves product development. And really the core are the teams. Cross-functional, self-organized, autonomous teams. And the other big difference is like we removed a lot of those layers, so you see a very flat organization. But we didn't change only the organization, we changed also the way of working. Of course, I'm a product person, so the best example I can bring today is give you evidence of our backlog. We started from basically the top left corner. This was basically our backlog 1.5 years ago, effectively 2 backlogs. On one side, business initiatives, on the other side, technical initiatives. And sometimes technical initiatives, honestly, were not even like, evident to business people. We rapidly moved on the other side of the screen, where we started to give visibility to tech initiatives. But, that was not enough. Guess what was deprioritized every time? Of course, tech initiatives. And this is instead our backlog today. There is really not tech or business initiatives. There are opportunities. Opportunities which basically are allowing us to progress towards our business and tech strategy. But organization and way of working, it's not enough. I mean, to really empower teams, we need a modern architecture. And this is what Carlo is going to talk to you about today.
So, she speaks for 4 minutes and she gets the applause. At the end, please, something that is at least 9 times stronger, because otherwise I have like personal safety issues then. So, this is what I call a thick architecture. It's thick as in vertically thick, a bit like a vertical organization, a pyramidal organization. You can see big systems, small systems. You cannot see the pointer, which is great. So you can see at the top something that is kind of an e-commerce. It has some HTML being rendered, it has a checkout logic, customer logic, stock logic, and of course it has its own persistence and its own big database that has plenty of stuff within. And you have plenty of big arrows which represent data moving around between, for instance, this system and other systems which in a retail, let's say omnichannel contexts are like order management, CRM, customer service over the phone, stores which need to sell. And all of these big arrows are chunks of data moving around, typically in big synchronizations, maybe more event-driven, maybe more batched, but at the end of the day, it's all about synchronizing different databases. And each of these databases pretends to be kind of the only thing around. It's self-delusional, but it thinks that it owns that data, and it behaves like it owns the data. So if you look at how, let's take stock information. So we have this product available or not at this stock level, whatever. Well, this same data needs to move around from, presumably it starts from the stock management system somewhere, and then it goes up into the enterprise service bus because, hey, it's a modern architecture. So you have enterprise service bus that is doing all the abstraction, and everything is going to be beautiful because you have an enterprise service bus, which is in fact a glorified adapter. And the stock data is moving to the order management system, is moving up to the e-commerce, is moving to the stores. Here I'm simplifying, but typically it goes also to some call center system, et cetera, et cetera, et cetera. So it moves around a lot. Now, what's wrong with data moving around a lot? Well, data is very detail-oriented, and typically logic gets attached to data. So if you have the stock information in your system, or if you have a personal information in your system, at some point, you have it in order to do some calculation. Maybe just to show it, but at least formatting it. You will be formatting it based on the data that you have. The more data you move around, the more logic typically you also move around. But logic doesn't really move around, typically gets re-implemented. So imagine that you have two carts. One is served by the e-commerce, and the other is served by the back office of the customer service over the phone. And the point is that typically people expect that if they buy some stuff, I will not mention which stuff, of course, online, you get kind of the same price if you call on the phone or if you go into the store. Normally, the price should be the same. So in order for the price to be the same in an architecture that is based around moving data around, well, you move the data, it's the yellow zone, but then all of the logic that is the green part there in the first layer, well, it needs to get replicated in the red zone in the other system that is serving the call center. So all of the same pricing mechanisms need to be aligned. And typically, they get replicated across different technologies. And when you want to evolve one, well, let's not forget to evolve all of the other pieces of logic. Okay? So this is the classic data transfer-oriented, thick architecture. But OK, in the last 15 years, some people have started talking about microservices, and some people were starting saying, no, microservices, we already have service-oriented. And say, yeah, but nobody understood service-oriented, so let's start talking about microservices, as in services that do very little. So we got to something like this. Something like this, you don't have the big blocks that contain functionalities and data. You have smaller blocks, then we can discuss endlessly on the size of these blocks. But let's say some size of blocks, which some people call microservices, I just call them data encapsulated within meaningful logic. And each of them has this clear responsibility. So in theory, all of your front ends, they still own the presentation, they still own the user experience, but when they have some price to calculate on top of a cart, when they have some catalog listing to show, in theory, they go to the same service. They go and ask to the availability rules service if some product is available for delivery in a given location, and then this service can collaborate with other services in order to give you the full answer. But in theory, you see the store front end and the customer service front end and the e-commerce front end are touching roughly the same galaxy of services. Now, this is better, in my humble opinion, compared to a data transfer and logic duplication-based architecture. But, I mean, it's still pretty thick, as in it has depth. If you want, we have replaced the data transfers with a deep call stack. You make a call, for instance here, the browser makes a call for a pricing, to get some pricing, and the pricing engine, well, it goes to the service that is listing the prices, so it's the price listing service, and then it's also making a call to the rebates service, which is probably having to access the customer information to know which rebates apply to this person, because, hey, we are all for personalization and whatever. So these are, you can picture them across multiple systems as the equivalent of a function calling another function, calling another function, et cetera, et cetera. And of course, this means that in this kind of architecture, if you lose your babies, so for some reason the pricing rule response is returning something strange, well, you are going down the call stack, except that this time you are going through multiple different systems trying to do the correlation and find which call was associated to which other call one level higher. Okay. And one other thing, of course, you're accumulating delays in communication, because this is not within the same runtime. These are different runtimes. So we want to stay with very, very close machines. I was working on this kind of architectures like 10 years ago, and I had the system administrator saying, yeah, no, your architecture will never work outside of our data center, because it's only us in our data center who can guarantee you that the pricing engine and the customer service are sitting within the same subnet, and they are connected to the same level 2 switch, so that the communication overhead is short enough. So it will never work in the cloud. So 10 years ago, it didn't strike anyone as surprising that, hey, we're talking about services, and you are telling me that this new thing, the cloud, is not good for services. The cognitive mismatch is amazing today, but back then it made perfect sense. Communication overhead is a big problem. And anyway, it's not entirely false. Typically, the fundamental reasoning, especially in early service or microservice architectures, was, yeah, you have maybe presentation that is built with some synchronous calls to an API gateway, but after the API gateway, your different services typically should communicate through mostly asynchronous calls, so that they can do parallelism, so that they don't get stuck if an answer is a bit delayed, so that you're really not necessarily accumulating all of the communication overhead the deeper you go in the call stack. So do it asynchronous. And so we get something like this, of course. The delivery service still has to communicate to the stock service, but probably is just making an asynchronous call with a callback and waiting for like call number 1 to be processed and to receive the callback saying, hey, reservation 1, okay. And then you're waiting for your fee calculation for the delivery to be performed, so that the call number 1, it's the green one, the colors need to be matched. When all the greens are notified back to you, then you can proceed and say, okay, now I have performed my delivery evaluation. Okay? Not difficult, right? Except that typically what happens if one of these processes takes longer or it gets refused, because one reason why you want to do asynchronous is that you want to kind of embed some resilience into your deep call stack. If you have 5 levels or 10 levels of 20 or 20 levels of call stack depth, if one of these calls is down, if one of these servers is not answering for some reason, where you are in trouble, maybe it's coming back in 30 milliseconds, but in the meanwhile, you have made your call, the call has failed, what do? You retry? Well, with asynchronous, typically, you do retry. You retry, but very often not in the original service. You start having kind of small enterprise service buses, small queuing systems with some retry logic. And of course, what happens if after you try 10 times? At some point, the thing becomes completely obsolete, and you have to notify the calling system that this is not going to go through anyway. So stop waiting and tell the user, sorry, something went wrong, with some funny icon if you are a startup, with a 404 or something stupid if you are a big company, but the message is the same. And then typically you put this call into, well, a dead letter queue. And you want to monitor this. You want to be able to say, OK, now I have like 10 calls that are in the dead letter queue. Maybe some of them are important. We need to replay them. Some of them, well, they are obsolete because they were live calls from a user. The user is gone now. So that's why you see people that were doing enterprise service buses years ago, let's say Mule, but frankly, anything goes with that, today saying that they are perfect for microservice architectures because they can give you all of these interesting asynchronous call management logic, etc. And they also do API gateways, by the way. So the complication is there. We have industrialized our modern architectures around the concept of being able to work asynchronously across multiple services, and also deploying easily the services, but we're not going to talk about that today. So this works, and once it works, of course, you apply it everywhere. So you have your services calling each other, and of course, for each of those calls, if you look in detail, well, you have this kind of stuff. Notification mechanisms, heavy payloads or light payloads. Are you implementing the observer pattern? Are you implementing an event queue? What is it? Well, for every need, you have a solution. For read-only, you typically go for lightweight notifications, etc. There is a whole world there. So that's life. Now, let's say in the last few years, something happened, which I call it the Google V8 engine. Not just the V8 engine, but the V8 engine sparkled a kind of arms race in browsers about speed. Every browser, all of a sudden, needed to be faster. And the ubiquitous front end of the early 2000s started becoming more and more of a computing platform. The first result, let's look at this state here. It's the same slide as before. Well, you had your front end doing its rendering, maybe owning the checkout logic a bit, not entirely, but owning the checkout, having a session. And then you had the mobile API. The mobile API was kind of a gateway that was going directly through the services. It was not presuming of providing you some aggregation, some rendering capabilities. No, it was just for the mobile applications. Well, why it was like that? Because the mobile applications were not presumed to be radically slow or radically non-standardized, like back in the day where a single JavaScript call was probably supported only by 3 web servers, and you felt that you were lucky if it was supported by 3 out of 4. So the mobile applications were kind of anticipating the API-centric architecture because they were removing the server-side rendering and navigation and session management logic, and they were doing it directly on the client device. But if the browsers are faster, then you can apply the same kind of distribution of logic. It's not a big problem if you have to do client-side rendering. Well, it is a problem for search engine optimization and all the stuff, but you can start putting more logic on the browser. We have seen presentation frameworks popping up more and more that are really using the power of dependency management in JavaScript, the homogeneity of functionality or relative homogeneity of functionality. If you don't have that, you can use Babel. And the computing power to have more and more logic. So this is your API-based, rendering agnostic, client agnostic architecture. Fine, but why was I talking about the depth? Well, because in fact, if you look closely at these kind of architectures, there are exceptions to this deep paradigm, even today. Your social login service is typically not directly, today, a few years ago it was, but it's not often directly connected to your server-side services. Very often it's your browser that is, well, it has some kind of token, cookie, whatever, that provides the identity of the user, and your, let's say, corporate services, they are trusting that identity because it's signed by an authentication authority, an identity provider that is trusted. And so the browser is making a call. Then it's making a call maybe to a payment service provider, and the payment service provider is not calling your order service and saying, hey, I just got a call from that guy, he paid. No, typically it gives you back a token that is a proof that you paid. And then the browser can send it back, the browser, the mobile phone, can send it back to your corporate services, and they do their magic. So this might seem like a small detail, but in my opinion, it's a major paradigm shift in the way we do multi-service coordination. So what if we apply massively this same approach to our own services in the company? Well, all of a sudden, you don't see any calls going back and forward on the server side of things. You only see this client entity, browser, mobile, whatever, making calls one after the other to different services, getting meaningful business payloads, like, I don't know, the pricing of the cart, the availability of a product, and maybe sending it back to the delivery evaluation service, which receives all of the information from the browser. And it doesn't have to go look around. You're doing business coordination entirely client-side, which is something that we were already doing, but you're doing it massively. So why I was saying that we're already doing, because, yeah, this is what you do for payment. You call a payment service provider, you get something, and you forward it to the orders. But what if you want to do delivery evaluation? Well, you are logged in, so the customer information, the browser can retrieve the customer information from your customer service based on the ID that you trust from the social login, for instance, or the social login, or in fact, your own identity provider, collect the customer information, then it makes a call to the stocks and says, hey, I have these 5 products I'm looking at right now. What's their stock state? Give it back to me. And then you can send it over, stocks and customer information, to the delivery service. If you want price, well, you send the same information to the price service, and the delivery service doesn't need to call anyone else. It doesn't need to call the customer reference. It doesn't need to call anything. It just owns the carrier information. It knows how quickly it can be delivered. It doesn't need to check the stocks because, hey, he has received the stock information from the client. And then finally, once it gives you proof that there is a delivery promise for this set of products for this destination, then your browser, your client, just has to send it to the orders. And the order system doesn't have to call anyone because it has all of this information. Now, yeah, but everything is happening on the browser. Everything is happening on the mobile phone. Everything is happening in the hands of the customer. If they decide to buy for free, they just have to change the data that they are going to provide to the order service, and they're going to receive some very expensive clothing free of charge. But we are not worried about this when we use distributed authentication. We are not worried that all of a sudden someone is going to masquerade as a person that is not, as someone else. No, because we have asymmetric encryption. We have a way to validate that some piece of information, if it has been signed by something, we can check that it has really been signed by that something. And we have mechanisms to reduce the security risk, like short-lived tokens, etc., for authentication, that are guaranteeing that we are not worried anymore about people impersonating someone else just because they logged in on Facebook. We trust that, and we don't spend many nights wondering, oh, what could ever happen? So why not applying this to everything? Why not signing every payload that every service has provided? And why not using asymmetric encryption to validate these signatures, no matter where they're coming from? Why reserving this beautiful mechanism only for identity information? Why not for prices? Why not for stock promises? We have all the mechanics for doing that. And we already do that for identities and for payments very often, and for other things. Every time you use some startup service, typically if it's some kind of sensitive information, you have a signature somewhere. And the beautiful part also is that you can use mechanisms like the JWT expiration of a signature to have clear, readable information that is signed, and it has a lifetime. How long your stock reservation lasts, well, that can be just modeled as the duration of your signature, of your package. So what if inside the browser we create a layer which is just a part of your business logic, just like everything that is sitting on the server side, and it is owning these pieces of business information which have a lifetime and they are trusted? Well, it means that you get complete modularity, very little dependencies on the server side, and you need to create a new kind of service. A service that is used to be fast in signing almost everything that it provides back, that is giving other services a way to validate the signature, that is serving what I call client-side deployable business logic and coordination, just as another thing that it serves, not only data, but also the piece of business logic that is used to understand and coordinate with other services on the client side, the data that it's providing upon call. It is still encapsulating data within some logic, but not the same kind of logic, very often a much more simple and minimalistic amount of logic. It's a service that is server-side isolated, as I was saying, and it typically is still a microservice. It's focused on one domain. And all of a sudden, the fact that it's focused on one domain doesn't mean that it needs to call 25 other different things. It can support his domain mission by just receiving signed payloads from a perfect platform for asymmetric computing, which is modern client-side and mobile languages. They are very good these days at modeling asynchronous behaviors. And these behaviors are very close to the user. If one of your calls fails, you just have to show the user. And you can be very elegant with it. You can say, yeah, we failed to reserve the stocks, but stay tuned. We are retrying. Oh, now it's done. OK, order placed. Thank you. Do that if this is happening at the 5th level in your cloud service of choice. It's super, super difficult to feed back to the user like this. It's like propagating exception stacks everywhere. I mean, we do that, but the complexity is enormous. So this is the idea. What if we build architectures as if every service did not belong to us, but belonged to a different company? And each of them is trusted because of asymmetric validations. And the last point is, remember the dead letter and the monitoring? Well, where is the middleware? Where is the enterprise service bus now? Where is it? Because it's there. It exists. It's the client. The client is the thing that is coordinating. The client is the thing that sees all of the communication. So maybe we have a different way, and I don't have a slide for this because I'm just dreaming this up, like the rest, which of course exists. What if we define a new class of microservice monitoring tools that are not so different from web analytics tools, and who are always very closely correlated to the person, because everything is happening in one browser session, client-side session, server-side is done. So they can tell you that this guy has lost his transaction to that service directly, just like today in Google Analytics, you know that they clicked on a button. Why not observing the business logic directly there? So this is it. I'm not saying that it has no problems. It's a different architecture, which is massively more parallel. And it has a different set of problems, but for me, it holds a new and interesting set of promises. And it makes internal and external services all the same. So that said, I don't have a big closure, so thanks.